Multiplying and dividing algebraic fractions. So again, the rules for multiplying and dividing fractions are no different when dealing with algebraic fractions versus dealing with numeric fractions. So there's no need to find common denominators when multiplying and dividing. We simply need to multiply numerators together and multiply denominators together. If we're dividing, we want to convert that into a multiplication problem by, instead of dividing by a fraction, we wish to multiply by its reciprocal. Okay, so let's have a look at some examples. So we've got x squared divided by x over 5. So again, like when you're dealing with numbers, if one of the things that you're trying to divide or multiply is not a fraction, you want to write it as a fraction. So x squared is just x squared over 1. And we're dividing by a fraction, so we want to change that to multiplication and take the reciprocal of the second fraction. I remember years ago some students telling me, oh, copy, change, flip. You copy the first thing, you change the sign to multiplication, and you flip the second fraction. Okay, so now we're just multiplying. Let's multiply the numerators together. 5x squared, denominators together, just 1x. Once you've multiplied or divided your fractions and got them together as one fraction, you then want to make sure that your answer is in simplest form. So here we have a common factor of x, so dividing the numerator by x gives 5x, and denominator by x just leaves us with 1, and so we just have 5x. Okay, example 2. So this looks a lot messier. So first thing I'm noticing is that we're dividing, so let's change that to multiplication and flip that second fraction. Let's get those fractions together as one fraction, and then we'll look at simplifying. You can do some simplifying as you go a little earlier. I like to follow the same kind of routine, both when I'm dealing with fractions. So generally I try to get them together as one fraction first and then do all the simplifying at once, but it is perfectly okay to do some simplifying earlier. Okay, so we've got x plus 2 over x times x minus 3, and we're dividing by this fraction, so I'm going to change that to multiplication and take the reciprocal of the second fraction. So you might want to do some cancelling down at this point. I'm going to put the two fractions together. So we've got x plus 2 times 2x times x plus 7. We generally write any terms that not in brackets at the front, so I'm going to put the 2x at the front. X plus 2, x plus 7, all divided by x times x minus 3 times x plus 2. Okay, so we've got a common factor of x, dividing both top and bottom by x, common factor of x plus 2, dividing top and bottom by x plus 2. So we're left with 2 times x plus 7 on the numerator, and x minus 3 on the denominator. You can expand out that numerator if you want. There's no need to, but it would be perfectly correct to do so. Okay, example 3. Okay, so we're multiplying two fractions here, so no need to copy, change, flip. So I'm simply going to multiply. Now you can do this in two orders. So you could multiply them together first and then look at doing any factorising. You could look to factorise first and then multiply them together. Particularly if you like to cancel down before you put them together, you might want to do the factorising first. So let's look at making sure all our numerators and denominators are factorised. So this first numerator has a common factor of a, and this first denominator has a common factor of 2. So that fraction itself doesn't cancel down at all. The numerator here is already factorised, 6 times a. Now the denominator here is a difference of two squares, a squared minus 1, so we're going to get a minus 1, a plus 1. Okay, so again, you might want to do some cancelling down at this point. You might want to put the fractions together first. I'm going to put them together first, so I'm going to do the a times 6a, so that's 6a squared, and we have that times a minus 1. On the denominator we have 2 times, now we've got a plus 1 times a plus 1, so we're going to have a plus 1 squared, and we've also got a minus 1. Okay, so we've got a common factor of 2, so we can divide the top and the bottom by 2, and we also have a common factor of a minus 1, so dividing top and bottom by a minus 1. So on the numerator we just have 3a squared, and on the denominator we have a plus 1, all squared. No more common factors, we're in simplest form. Okay, example 4. So things are getting much uglier here. And again, you might want to put them together first, then worry about factorising and simplifying. I would probably factorise pretty early on in the process. So I'm going to factorise each of those 4 expressions. I'm also going to change the division to multiplication and flip the second fraction. We'll see if we can do all that at once. We've also got a harder quadratic on this numerator here. So I'm just going to quickly factorise that over here. Might run out of space here. Let's write a bit small. So we're going to do 2 times negative 5, which is negative 10. Factors of negative 10 that add up to positive 9. It's going to be plus 10x minus 1x. Again, you could put them in the other way around. 2x is a common factor in the first 2 terms. Negative 1 is a common factor in the second 2 terms. And so we're going to get 2x minus 1 times x plus 5. Okay, so let's go back over here. So I'm going to put that factorisation in place of the expanded version on the first numerator. It's a 5, sorry. The denominator here is a difference of 2 squares, so x plus 5x minus 5. And actually that fraction cancels down itself, so we might do that. The second, I'm changing it to multiplication, so I'm flipping. So we're looking at the denominator here, which has a common factor of x. And the numerator, which is now the denominator, is a simple quadratic. Factors of 20 that add up to 9, plus 4 and plus 5. Okay, so within each fraction we've got some things that will cancel down. So I'm going to divide this second fraction top and bottom by x plus 5, and the same with the first fraction. Let's get rid of all of those. Okay, so now what we've got is 2x minus 1 over x minus 5 multiplied by x over x plus 4. Let's put those together. So we've got x times 2x minus 1 over x minus 5 times x plus 4. Now everything there is factorised, so we can see really clearly whether there's anything further that will cancel down. There clearly isn't. We've got 2 factors on the numerator and 2 factors on the denominator, but nothing in common between the 2. And so that's as simple as that gets. You can expand that numerator and that denominator out if you wish, but there's absolutely no need to, and we've answered the question at that point. So I wouldn't bother personally. So in summary, I would start by factorising all the numerators and denominators, particularly in an example like that previous one where you've got quite a bit going on. You might find each of the fractions individually simplifies a little bit before you do your multiplication and your division. So I would do all my factorising first. For division, you want to change it to multiplication and multiply by the reciprocal. For multiplication, so once you've got it as a multiplication, you then want to multiply your numerators together, multiply the denominators together. Don't expand. You've got everything factorised if you leave it in brackets, and then you should be able to see whether you've got any common factors that will cancel down. You want to make sure that your final answer is given in simplest form, so looking for any common factors and dividing both numerator and denominator by those common factors.